Hello everyone, and welcome to another video tutorial. Now in this presentation, we'll be looking at reconstitution calculations. Alright, so there are some APIs and drugs that by their very nature are unstable in the aqueous environment, even when they are exposed for short periods of time. An example would be your antibiotics. These are classic examples of drugs that are unstable in aqueous environment. And so to increase or enhance the shelf life of these types of drugs, they are typically prepared or formulated as a dry powder. So they go through a freeze drying process or a lyophilization process to get them as a dry powder. The thing about these kind of drugs is if you're going to use them parenterally, you need to basically put them back into true solution before you can inject them. So that's where reconstitution comes into the picture. Reconstitution is essentially the process through which you take a dry powder drug and completely dissolve it using a diluent. And typically the diluent that you'll be using is sterile water for injection, bacteriostatic water for injection, and so on. So you add a specified volume based on the formulation parameters of diluent to the dry powder, and that gives you your reconstituted preparation. You just want to keep in mind that your final reconstituted solution should be free from particulates of any kind and should basically be clear. Those are a few things you want to keep in mind. Alright, so in this tutorial, we'll be looking at the sources of the diluent. I mean, where do you get the information on how much volume of diluent to add? We'll look at that. Then I'll take you through three strategically selected examples. One will illustrate how you calculate powder volume, and I'll talk about that parameter down the line. And then the other example will look at how you determine the dose calculation once you have got a reconstituted preparation. And then the last example will illustrate how you compute the volume of diluent given the other variables. Alright, so before we get into the main calculation section, on some level we are all familiar with reconstitution. A classic example would be the Kool-Aid, which typically most kids really love. Right, so when you look on the package, it gives you some directions. It tells you how much water to use to dissolve a packet of the Kool-Aid so that you get the flavor. So it tells you to use, for each packet, just put that into a 16.9 flower ounce bottle of water, or 0.5 liters of liter bottle of water, add the packet to it, dissolve it, and then you should have your Kool-Aid. Now, for most people, that should taste okay, and that will be a certain specified concentration. Alright, but if it's too sweet for you, you probably would then add a little bit more water so that it's good for your taste, and that means it to be more diluted. And if you like it extra sweet, you probably will use a little bit less of the water that has been specified. So just keep that analogy in mind as we go through some of the examples that we need to look at. Alright, so first of all, let's talk about where we find the information on how much volume of diluent to add. The first place you get that information is on the vial label. So the label has the vial will have a label, and on that label, most of the time you'll find how much volume to use. So in this example where you have the Zithromax powder, it tells you on there to constitute to 100 milligrams per milliliter with 4.8 ml of sterile water for injection. So the volume to add has been given as 4.8 milliliters. Now, there are a few of us who already be curious and will note that this is a 500 milligram preparation. How do you then add 4.8 mLs and end up with 100 milligrams per milliliter? That's because the powder is contributing some volume, and in this case, I can tell it's 0.2, but we'll look at powder volume down the line. So the first place you find the information is on the label of the vial. All right. Now, sometimes you do not find the information on the vial. Like in this example, it gives you a whole bunch of information. It tells you you have 1 gram of ceftazidime. But you notice that there's no place on the vial label that you see the volume to add. So in this instance, what you want to do is look at the additional place where you can find that information, and that will be in the package insert. Right, so I'm going to just show you where you find that on the package insert. So now on the package insert, this is for the product that I just showed you. I'm just going to quickly take you to the page because I know where it is on page 11 here. So you just go through it, you navigate nicely through it. It tells you a whole bunch of good information, the dosing and so on. But for this particular time, you're interested in how much volume to add. So where it says preparation of solutions of tacecef, we can see how much diluent to add if we look at the second column. So in the second column, it gives us amount of diluent to be added, and it tells you what to do, whether you're giving intramuscularly or intravenously. So for an IM or an intramuscular injection for the 1 gram vial, it tells you to add 3 milliliters. And once you do that, the total volume in there will be about 3.6 ml, and then your final concentration is 280 milligrams per milliliter. Now notice that if you are given an IV infusion for the 1 gram and 2 gram vials, you are required to add 10 ml of the diluent. However, your final concentrations are slightly different. For the 1 gram IV infusion, you end up with a final volume of about 10.6, and your concentration is 95 milligrams per ml. And you notice for the 2 gram, you end up with about 180 milligrams per ml as concentration. So the second place you can find information on how much volume to add is in your package insert. So now that that is clear, let's talk about powder volume. So we notice in a few of the examples that even though we're given the amount of volume to add, if we simply divided the quantity of the dry powder in the vial by that volume, we will end up with a different concentration than what was specified. Now that difference actually has to do with what is known as powder volume. So powder volume is essentially the space or volume occupied by the powder in the dry powdered preparation. So there are some instances where you'll find out that the powder volume is negligible, so your volume of the diluent will essentially be the same as the final volume. And an example will be what we see when we look at the vial size 125 milligram in this particular table. The diluent volume was 1 ml, our final volume is 1 ml, and so the powder volume, the contribution from the powder is essentially 0. All right. Now there are several instances where the volume of the powder is not negligible. It actually contributes some significant amount, and so you want to factor that into consideration because it affects in some ways your final concentration. That's what it would affect. So if you look at the 500 milligrams, you add 1.8 ml of diluent, you end up with a final volume of 2 ml, and the powder volume is 0.2 ml. That's because you subtract the diluent of the volume of the diluent from the final volume to determine the powder volume. Same thing for the 2 grams. 6.8 ml of diluent gives you final volume of 8 ml, and you end up with the powder volume of 1.2. So the more significant the powder volume, the more difference it will make in terms of factoring that in when you're calculating the final concentration. So this actually is the most important equation when it comes to computing or calculations involving reconstitution. And it says your final volume is equal to the volume of the diluent plus the powder volume. Alright, so this equation is what you want to have stenciled in your mind. Okay, so I already talked about how the final volume is equal to volume of diluent plus powder volume. However, you will notice that there are some times when you're doing these calculations that they don't, directly give you the final volume. And then students always get confused. Okay, what do I do now? So what I recommend is a variation of this equation. And that would be understanding that the final volume is related to the quantity of the drug and the final concentration. Those three parameters all are interrelated. And so the way you could also think about it is to notice that your final volume is equal to the quantity of the drug divided by the final concentration. So if you understand that relationship and you substitute that information into the original equation, you come up with a derivative of that equation, which I find to be more beneficial to students when it comes to some types of calculations regarding reconstitution. Okay, so this quantity of a final concentration equals volume of diluent plus powder volume is a very powerful equation that you can use. Alright, so now we'll jump into those three examples I was talking about. We'll first start off by looking at the calculation involving determining the powder volume, and then we'll look at the next example where we are using the reconstituted preparations concentration to determine the dose for a particular patient. And then in the third example, we'll look at how you determine the volume of diluent given the other parameters presented in the equation. Alright, so let's jump right in. Alright, so the question, like I was saying, says 1 gram of ceftazidime must be diluted with 3 ml sterile water for injection prior to intramuscular administration. The resulting solution contains ceftazidime 280 milligrams per ml. What is the powder volume of the drug? Alright, so notice that you've been given a few numbers in here. The 1 gram is the original quantity of drug in the vial. The 3 ml is the volume of your diluent, and the 280 milligrams per milliliter is your final concentration. So we are supposed to find the powder volume. Alright, so the equation that you want to use is, it says final volume should be equal to the volume of your diluent plus the powder volume. But like I said, you are not given your final volume directly. So we want to use the derivative that I was recommending. This is something I teach all the students that I come across. And that will be the quantity of your drug divided by the final concentration should be equal to the volume of the diluent plus the powder volume. And so we do know the final concentration is 280 milligrams per milliliter, and our quantity is 1 gram. So just to keep the units consistent, we want to convert the grams to milligrams, and a gram is 1,000 milligrams. So 1,000 milligrams divided by 280 milligrams per milliliter should be equal to the volume of your diluent, which is 3 ml, plus what we do not know, the powder volume. And so according to the calculator, 1,000 divided by 280, that should give us about 3.57 equals 3 ml plus X. And so we can easily solve for our unknown if we subtract 3.5 from both sides. Okay, so this will imply that x is equal to 3.57 minus 3, and that should be equal to 0.57 ml. Alright, so the powder volume in this instance is going to be 0.57 ml. Okay, and so just to recap, notice that you want to use this form of the equation. Quantity of drug divided by final concentration equals volume of diluent over powder volume. That's because your final volume is basically the same as this ratio right here. Okay, so if we do that, the other key thing to note was we converted the grams to milligrams so that the units are consistent, and then the rest was we substituted the ratio. We basically calculated that on the using a calculator, ended up with 3.5 ml, and then we subtracted the 3 from 3.5 to get 0.57 ml. So that would be the volume, or your powder volume, in this particular example. Alright, so let's look at the next example, which talks about dose calculations from reconstituted medications. So now let's take a look at the second example, which actually involves determining a dose calculation once you have the final concentration of a reconstituted preparation. So he says a medication order calls for 400,000 units of penicillin G sodium to be added to 1 liter of D5W. Available in the pharmacy is a vial containing 5 million units. The manufacturer directions are to add 8 ml of diluent to get a concentration of 500,000 units per ml. How many milliliters of the reconstituted solution will be needed to prepare the order? Alright, so at first glance, you have so much going on here, so many different numbers. You have 400,000 units, you have 1 liter, you have 5 million units, you have 8 ml, you have the concentration 500,000 units per ml. So what do? Alright, now whenever you have a situation where you're calculating the dose and you know the final concentration, you basically simply just set up a ratio. That's what you do. Alright, so we're going to look at this equation. We can analyze it some more. The patient is supposed to be given 400,000 units. That's the dose for the patient. But you're going to give that as a volume, okay? And so we look through, we find out that this 400,000 units is added to 1 liter of D5W. So this 1 liter D5W, or dextrose 5%, is your carrier or your large volume parenteral. That's the bag where you're going to put the drug in. Okay, so we don't need this quantity for any of the calculations in this particular example. Once we figure out how much volume you're going to need, we're going to put that volume into this bag, this 1 liter bag. Okay. And also it tells you that you have a vial that contains 5 million units. So that's the total quantity of drug in your vial. It gives you how much volume to add. That's the volume of your diluent. But the thing about the question is it actually gives you the final concentration. How do we know? It's units per volume, units per ml. Alright? So because we know the final concentration, all we need to do is basically set up a proportion. So what we will say is, since the concentration is 500,000 units per ml, it means you have 500,000 units in each milliliter. We want to give our patient 400,000 units. That's what we want to do. So what will be the volume? Okay, so once you know the final concentration of your reconstituted preparation, anytime you're going to give a dose, you set up a proportion or some kind of ratio this way. Alright, so we're going to solve for X, which is our unknown, and that should be basically 400,000 units divided by the 500,000, so basically times 1 ml divided by your 500,000 units. So units cancel out, all these zeros cancel out, and so 4 divided by 5 is essentially 0.8 ml. So our volume, this is L, our volume is going to basically be 0.8 ml. Okay. So as you notice, there was a lot going on. There are so many numbers and so much information. But just to recap, the thing you want to look out for is anytime you're calculating the dose, just make sure you know what the final concentration is. If it's not given, you have to calculate it. Right? In this question, it so happens that it was given to us as 500,000 units per ml, and so we set up this proportion to basically determine our unknown. We solve for X, and if we do that, we end up with 0.8 milliliters. Alright, so now let's look at the third example where we are determining the volume of a diluent. Alright, so what we want to do is it tells us that the label instructions indicate to add 3 milliliters of sterile water for injection to 1 gram of ceftazidime to give a final concentration of 280 milligrams per liter. How many milliliters of your sterile water for injection should be used to prepare the following order? Alright. So once again, you have quite a bit going on here. Let's just clarify what's going to happen. We've been told that if we looked on the label or the vial label or looked in the package insert, we're supposed to add 3 ml of the diluent, that is sterile water for injection, to 1 gram, and that should give us 280 milligrams per ml. So that's given. But what's happening is you have an order from a physician, and this physician wants to end up with a concentration of 250 milligrams per ml. So if you remember my analogy with the Kool-Aid, this would be one time where maybe the Kool-Aid was too sweet and so you wanted to dilute it. Same thing here. The concentration that is specified by the company that formulated this product is 280 milligrams, but the physician wants something which is a little bit lower, 250 milligrams per ml. So we can't simply add the recommended volume of the diluent. Alright, so what do? We're going to do this in 2 steps. The first thing we are going to do is use the information that has been given, which is the 3 ml, 1 gram, and 280 milligrams per ml, to find out what the powder volume is. And once we know that, we'll go back and use our quantity and the new concentration together with the volume of the powder volume to determine the volume of diluent. So this is what I mean. First of all, we know that the quantity of drug divided by the final concentration is going to be equal to the volume of your diluent plus the powder volume. Okay? And so what that means is we have 1,000 milligrams, and this is from the 1 gram, divided by the 280 milligrams per ml, and that should give us 3 ml plus the powder volume, which we do not know. Okay. So we're going to pull this up a little bit. We are done with that piece of information. And if we solve for our unknown, we're going to end up with, on this side of the equation is 3.57 equals 3 ml plus x. So the x is going to be equal to 3.57 minus 3, which is 0.57 ml. So that's the powder volume. So now that we know that, we are going to make use of the new concentration. Okay, so the new concentration is such that you have your powder volume. So your new concentration is going to be quantity of drug over final concentration being equal to volume of your diluent plus the powder volume. And so what we will have to do now is use the new final concentration. And our new final concentration is 250. Okay? So we end up with 1,000 milligrams divided by 250 milligrams per ml. And that should be equal to what we do not know plus the powder volume that we just figured out, which is 0.57 ml. So on this side, we will have 4 milliliters. We don't know what the volume of the diluent is, but we know the powder volume. Okay? So we can now solve for the new volume, which would be x equals 4 minus 0.57 ml, and that will be equal to 3.43 milliliters. All right, so the volume of diluent is going to be 3.43, and if we compare it to the original volume, it's higher, and we expect that we will need more diluent to have a lower concentration. All right, so let me just quickly go through the high points once again, because this was fairly long. The first thing you want to do is use the information given earlier to determine the powder volume. That's what we use the 3 ml, 1 gram, and 280 milligrams per ml for. That gives us powder volume, which would be basically the 0.57. Okay, so that gives us this as the powder volume. And I will make use of that information together with the desired concentration, which was 250 milligrams, to determine the volume of powder. And that's what happens down here. Okay, so now we have the powder volume, and the powder volume for a particular drug would not change for a given drug. All right, so we use that information again, and this time we make use of the new final concentration, and that gives us, at the end of the day, the volume of diluent to be 3.43 milliliters. So I hope you found this video tutorial useful. If you liked it, just click the like button, subscribe to the channel. Be sure to check out our website, www.RxCalculations.com, for more information about pharmaceutical calculations. And if you have any questions, be sure to send me an email at profmdankwa@rxcalculations.com.